Mohs scale. The Mohs scale of mineral hardness is a qualitative ordinal scale, from 1 to 10, characterizing scratch resistance of minerals through the ability of harder material to scratch softer material. The scale was introduced in 1812 by the German geologist and mineralogist Friedrich Mohs, in his book
Versuch einer Elementarmethode zur naturhistorischen Bestimmung und Erkennung der Fossilien.
It is one of several definitions of hardness in materials science, some of which are more quantitative. The method of comparing hardness by observing which minerals can scratch others is of great antiquity, having been mentioned by Theophrastus in his treatise on stones. C.A. 300 BC. Followed by Pliny the Elder in his Naturalis Historia, c.A. AD 77. The Mohs scale is useful for identification of minerals in the field, but is not an accurate predictor of how well materials endure in an industrial setting. The Mohs scale of mineral hardness is based on the ability of one natural sample of mineral to scratch another mineral visibly. The samples of matter used by Mohs are all different minerals. Minerals are chemically pure solids found in nature. Rocks are made up of one or more minerals. As the hardest known naturally occurring substance when the scale was designed, diamonds are at the top of the scale. The Mohs hardness scale is a set of 10 reference minerals, numbered 1 through 10, that are used to determine the relative hardness of minerals and other objects. A Mohs hardness scale kit containing 1. Talc, 2. Gypsum, 3. Calcite, 4. Fluorite, 5. Apatite, 6. Orthoclase, 7. Quartz, 8. Topaz and 9. Corundum. Diamond, 10, is not included in most kits to keep the cost down. The hardness of a material is measured against the scale by finding the hardest material that the given material can scratch, or the softest material that can scratch the given material. Scratching a material for the purposes of the Mohs scale means creating non-elastic dislocations visible to the naked eye. Frequently, materials that are lower on the Mohs scale can create microscopic, non-elastic dislocations on materials that have a higher Mohs number. Talc is the softest of them all. Talc is numbered 1 in the Mohs scale, meaning it can't scratch other materials, therefore talc can get scratched by everyone else. Talc has some daily uses such as, dusting powders, lubricants, leather dressings, etc. Gypsum is numbered 2 in the Mohs scale, meaning it can scratch materials such as talc and other materials with hardness 1. Gypsum has some key appearances in our daily lives in the form of toothpaste and shampoos. Calcite is numbered 3 in the Mohs scale. It can barely get scratched by a copper penny. Some of the uses of calcite include, as a building material, pigment and as pharmaceutical ingredient. Fluorite is numbered 4 in the Mohs scale. Besides having a large spectrum of possible colors in which it can occur naturally, it has uses in cooking utensils, camera lenses and high-performing telescopes. Apatite is numbered 5 in the Mohs scale, therefore it is a great mineral specimen to be used as a gemstone when quality crystals are formed. Feldspar is numbered 6 in the Mohs scale. It has many uses such as being implemented in drinking glass, floor tiles and even shower basins. Quartz is numbered 7 in the Mohs scale. It is used in many aspects of our lives including jewelry. However, its most popular use is in glassware and clocks. Topaz is numbered 8 in the Mohs scale. It has an endless quantity of possibilities in terms of color, no wonder its use in jewelry. Topaz is also implemented in making refractory materials. Corundum is numbered 9 in the Mohs scale. Its two most common variations, Ruby and sapphire are commonly found in fine jewelry. Corundum is also used in the grinding of optical glass and the polishing of metals. Diamond is numbered 10 in the Mohs scale, therefore it is the hardest material. It is most commonly used in fine jewelry and its colors variations are rare. Diamonds are also used in the industrial world.